Welcome to Grateful, where we offer online SAT and ACT instruction to students all around the world. Our unique approach to the SAT is rooted in the idea that the SAT is a content-based test, and a deep familiarity with that content will have you knowing what to expect before you even step foot in the big test. Right now, we're working on SAT Practice Test 6, Section 3. The best way to take advantage of this video is to access Practice Test 6 on College Board or Khan Academy's websites for free. Go ahead and do this section on your own, and then refer to this video for the most effective ways to answer the questions. Let's go ahead and get started. Question 1. This question here is giving us an equation t equals 15n plus 12. And it's asking us, what does the 12 represent? What's really going on here is that this is a y equals mx plus b type of equation. You can tell that because of exactly how nicely it lines up with the equation t equals 15n plus 12. Now the concept that we're dealing with here is the idea of translating slope or translating y-intercept. The SAT will often have you explain what the slope and the y-intercept mean in the terms of a given problem. If they were asking you for the slope, you would say to yourself, slope is change in y over change in x, and then substitute in the terms of this problem. So in this problem, the y is the t and the x is the n. So if we were saying change in y over change in x, then that would be the change in t over the change in n. And we have to stop and look at what t and n represent. T is the amount in dollars being paid, and n is the number of tickets. So the slope represents the change in the price per ticket paid, or the amount paid per ticket. Now to understand what y-intercept signifies, just imagine you have this xy axis here, and you have your y-intercept, which is the b, and in this situation is 12. And then from there, you have the change, the rate of change of the line, which is the slope, and that changes at a rate of 15. And like we said before, it's $15 per ticket purchased. So we've got a deep understanding of what the y-intercept and the slope are, and the y-intercept is kind of the starting amount of money before any tickets are being purchased. Now this question goes one step further and tells us that there's actually a one-time service fee. So if we're talking about the starting amount of money, it's the one-time service fee. It's the amount that you've paid before you've actually bought any tickets. And for question number 1, that's answer choice B. Question number 2 is a question that's quizzing us on price times quantity statements. Here in this problem, we have the amount of fertilizer that's being purchased, and among the fertilizer, a certain percent of that is the filler materials. So for instance, if we have X pounds of fertilizer A, because the question tells us that X represents the number of pounds of fertilizer A, we're also being told that for fertilizer A, 60% of that is filler material. So if I want the amount of filler material, that's the amount of fertilizer multiplied by 0.60, because 60% of that is filler material. Now that could be thought of as a price times quantity statement. There are X pounds of fertilizer, and for each of those pounds, 0.6 of that is filler material. Now we can do the same thing for fertilizer B, because Y is the number of pounds of fertilizer B. So we have Y, and 40% of that is filler material. When we add both of those up, the question tells us that the total amount of filler material is 240 pounds. So we set that equal to 240, and this exactly matches answer choice B for number 2. Question number 3 gives us two equations that are both in the a plus bi format. And the important thing to know here is that the a and the b are different kinds of numbers, because the numbers 2 and 4, those are just regular real numbers, but the 3i and the 8i, the b's, those are complex numbers, imaginary numbers. And the reason why we're emphasizing that is that they can't be combined with one another. So if we're looking for the sum, we're going to take the 2 and 4 and combine those together, and that'll give us 6. And we can also take the 3i and 8i and combine those two together, and we'll get 11i. Therefore, the answer for number 3 is C, 6 plus 11i. Question 4 is an important question in terms of understanding what the SAT is doing throughout the math section, and what it's giving us is references to underlying ideas that we're supposed to light up when we see. So here, the idea is the idea of a difference of squares. For instance, if we had a squared minus b squared, we need to know that that'll factor to a plus b times a minus b. Now, a difference of squares is called a difference of squares because it literally has a minus sign, that's the difference part, and two perfect squares. So literally, it's a difference of squares. The way a difference of squares factors is you have the square root of each component. So the square root of a squared goes there, it's a, and the square root of b squared goes there, and it's b. And it's the square root of each piece with a plus and a minus sign. In this situation, we have the difference of squares 4x squared minus 9. And once we identify that there's a minus sign right there that makes it a difference, and two perfect squares, then we can just take the square root of each piece. So the square root of 4x squared is 2x, and the square root of 9 is 3. So we'll have 2x plus 3 and 2x minus 3, and that's how it factors. So the question tells us that those are in the format of px plus t and px minus t, and then it asks us which is the p. And as you can see here, the p is the 2. The 2 is in the same spot as the p in the given formula. So we can pick answer choice A for number 4. Question number 5 is essentially asking us to graph the equation y equals 2x minus 5. And once again, what we're seeing is a line in the y equals mx plus b format. According to that, our m is 2 and our b is, so what would all this mean on an xy axis? If the b is negative 5, that means that to graph the line, we would first go to negative 5 on the y-axis, and then from there, the slope of the line would be 2. And the rule here is that slope is rise over run as you go from left to right. We often hear in school that slope is rise over run, but we can't forget the idea that that's as it's going from left to right, because that'll help us determine whether the slope is positive or negative. So here, as we're going from left to right, we're going to have a slope of 2. Now, by the way, a slope of 2 means the slope is not just 2, but it's actually 2 over 1, because any number is really itself over 1. But because we're talking about the slope as the rise over the run, it's important to really express it as a fraction. So as we go from the y-intercept of negative 5, we're rising and running 2 and 1. So we're going to go up 2 and over 1. And that takes us to this point right here. And then we can just connect those points with a line. And now we have a nice idea of what our line looks like. And the answer choice that most closely resembles what we just did is answer choice D. Question 6 gives us a couple of equations that we can combine. We have the equation x equals 2/3 y, but we're also being told that y is 18. So let's just go ahead and plug in that 18. X equals 2/3 of 18. And what's 2/3 of 18? That's just 12. So we now know that x is 12, and we can plug that in to 2x minus 3. So that'll be 2 times 12 minus 3. 2 times 12 is 24, so 24 minus 3, and the answer to that is 21. So the answer for 6 is A. Question number 7 is giving us an equation and asking us to solve to express L. So in other words, they're asking us for L in terms of N and H. So we have the equation N equals 7LH. And the concept here is, if you want to get a variable by itself, you have to ask yourself what's happening to that variable, and then you can do the opposite of that. So what's happening to L right here? L is being multiplied with 7 and H. So what's the opposite of that? We're going to divide it by 7 and H. So right now we have L by itself on the right-hand side because the h's canceled and the 7's canceled. On the left-hand side, we have n over 7h. So what's L equal to? It's equal to n over 7h. And that matches answer choice C for number 7. Question 8 gives us this confusing looking table, and then it gives us an expression to satisfy. So the expression is that w of x plus t of x has to equal x. So let's just try that for the different values of x. When x is 1, at that moment, w of x is -1 and t of x is -3. So -1 plus -3 is supposed to equal 1. And of course, -1 plus -3 is -4, so that doesn't work. For x equals 2, we have w of x equals 3 and t of x equals -1. So we have x equaling 2, and we have 3 and -1. And the equation says that we're adding those two. So is 3 plus -1 equal to 2? Yes, indeed it is. So for which value of x is the expression true? Well, we already found our value of x. It's 2. Answer choice B. Question 9 is a question about radicals that's very easy to overcomplicate. First of all, when you have a square root of something, that's going to have a positive and negative scenario. So for instance, the square root of 25 would be plus or minus 5. So we always want to be aware of that, but we're not quite sure on which questions will that be a big deal. But in this situation, we have square root of x plus square root of 9 equals square root of 64. And before we get into all the plus and minuses, let's just try to solve it the easier way first. So square root of 9 is simply 3. Square root of 64 is simply 8. So radical x plus 3 equals 8. Now we can just take away 3 from both sides, and we'll get square root of x equals 5. How do we get rid of the radical? By doing the opposite, by squaring it. So we can square both sides here, and that'll give us x equals 25. And that's showing up as one of the answer choices, so we never really have to ponder the possibility that the radicals also had negative options. And the answer for number 9 is C. Question number 10 is a great example of a general approach to solving SAT math questions. Often, if we ask ourselves, how do I get the answer in a specific situation? That's kind of tough, and it doesn't really let us know where to go next. But instead of asking ourselves that, why don't we ask ourselves, what can we do with the information we're being given? So here, I would say the unifying statement for the whole thing is that Jamie's goal is to bicycle an average of 280 miles per week. And that's at least 280 miles per week. So what that's basically telling us to do is to set up a statement that says that the average we're talking about here is at least it's greater than or equal to 280. Now, at least is the same as greater than or equal to, because if I'm at least a number, that means that being that number is okay, and being greater than that number is okay. So the average is greater than or equal to 280. Now, a nice easy concept here is that the average is the sum over the number. And even though that sounds really easy, it's really useful to often just nicely set up an equation as the sum over the number. In this situation, we have the first week, which was 240, the second week, which was 310, the third week, which was 320, and the fourth week, which is being represented by x. And that's going to be divided by the number of weeks, which is 4, and that needs to be greater than or equal to 280. Now to simplify, we can just multiply both sides by 4, and that'll get rid of the denominator on the left-hand side. Now if I were really doing this, I probably would have combined the like terms first, but trying to keep it in line with the answer choices, we're avoiding that. So we'll let the 4's on the left-hand side cancel out, and that'll give us 240 plus 310 plus 320 plus x is greater than or equal to 280 times 4 on the right-hand side. And that exactly matches answer choice D for number 10. Question 11 is asking us pretty much about the vertex formula of a parabola. The vertex form of a parabola looks like this. Y equals a x minus h squared plus k. Now the h and the k represent the vertex of the parabola. But notice that the h is negative and the k is positive. This means that if something is added to x on the inside of the parentheses, it represents a horizontal shift, and it's backwards, which means that if there is a positive number there, then it would shift the function to the left. And if there's a negative number there, it would shift it to the right. But the thing that's being added on the outside, the k, that is the vertical shift. And because in the formula it's positive, that means that it's normal. So if you see a positive number added to the outside of a parabola in vertex form, then you know it's shifted up. And if you see a negative number there, then it's shifted downward. Now the a in the vertex formula, that number will tell you how tall and thin or wide and narrow the parabola is, but more importantly, the sign of it tells you the opening direction of the parabola. If it's negative, the parabola will open downward and will look like an upside down U. And if it's positive, the parabola will open upward and will look like a regular U. So in our question, we're seeing that there's a negative sign in that very spot, which means the parabola is opening downward. So the only answer choices that can work for us are answer choices B and D. Now inside of the parentheses, we have something being subtracted from x, and that is normal for the vertex formula of the parabola. We said that when something is negative added to x on the inside, it's shifted to the right. And so we know this thing is shifted to the right by the amount of b. And the thing on the outside, that's our vertical shift, and that is normal. So if we see a plus sign there, it's up. So this is going up by c. Now this function is going right by b and up by c. So that's telling us that the vertex goes to the right and up. And so generally it's somewhere around here, and the parabola opens downward. So we would expect it to look something like this. But with the vertex of it in this general area, in what we would refer to as the first quadrant, this quadrant in the upper right-hand side is the first quadrant. And by the way, the upper left-hand side, that's the second quadrant. The lower left-hand side, that's the third quadrant. And the lower right-hand side, that's the fourth quadrant. And yes, you do need to know that for the SAT. But in our situation, any number that is in that first quadrant right here is going to have a positive x value and a positive y value. And that's answer choice B for number 11. Now question 12 is a question about division of polynomials. We can tell it's about division, possibly because some of the answer choices look like the results of division. When you divide and you end up with a remainder, the remainder becomes the numerator with the thing you're dividing by as the denominator. So seeing x or x plus 1 with minus 2 over 4x plus 2, that stinks of division of polynomials. Now this is also a very special question type that the SAT does something really strange here, which is the idea that if you do synthetic division with this set of numbers, for whatever reason, it will not get you an answer that matches the answer choices. So with some really interesting numerical acrobatics that College Board is doing here, they're forcing us to do long division of polynomials. So let's go ahead and walk through that. By the way, we have videos in our library about long and synthetic division of polynomials, and if you need a little refresher, go ahead and look through our older videos. But we're going to go ahead and divide 4x squared plus 6x plus 0. Now yes, you need to put that 0 there when you're dividing because you need something to occupy every space. The x squared space, the x space, and the constant space, which is when x is actually to the 0 power. and that's being divided by 4x plus 2. So this is exactly analogous to what you would do if you were dividing regular numbers using long division. And on the non-calculator math section, you're probably going to need to be sharp on that. So brush up if it's something you haven't done in a long time. But the first thing you're going to ask yourself is, what do I need to multiply 4x by to get 4x squared? And the answer to that is x. And if we go ahead and distribute that x back into the original expression, we're going to get a positive 4x squared and a positive 2x. Now, an important concept with long division of polynomials is that you have to write all of the signs for all of the numbers you're working with, because most of the mistakes here will come from small little calculation errors that had to do with losing or confusing a sign. So we're going to write the plus before the 4x squared, and then if you were doing regular division with regular numbers, this would be the moment where you put a minus sign right here. But minusing, subtracting for a polynomial actually means that we're distributing a -1 into each term. So instead of putting a big minus sign there, we're going to take each term and circle it and indicate that the sign has been flipped. So not only do you need to flip the sign, but you need to do it with good enough handwriting that you can look at it and know what was the sign before and what was it after, in case you lose your train of thought. Now we'll go ahead and subtract straight down. 4x squared minus 4x squared cancels. 6x minus 2x becomes 4x. And just like in regular division, at this step, you go ahead and lower the next number. So now we have 4x plus 0. And just like we did initially, we're going to ask ourselves, what do we need to multiply 4x by to get 4x? And the answer is nothing. You can multiply it by 1 because we already have the 4x. So we'll multiply it by 1, and then we'll distribute that 1 back into the original expression. So 1 times 4x is 4x, and you put the sign on it. And we should have put the sign here because we want to put the sign on every number we're working with. And 1 times 2, which is 2, positive 2. And now we'll subtract straight down, like we said, by taking each sign and physically reversing it. So 0 minus 2 is -2. 4x minus 4x cancels, and we have, at the end of all of this, a remainder of -2. Now, like we said in the beginning, when you're dividing, the remainder goes as a numerator over the denominator, which is the thing you're dividing by. So the answer here would look like x plus 1 minus 2 over 4x plus 2. And that exactly matches answer choice D for number 12. Question number 13 is a question about the discriminant. Now, when you have a quadratic, this is a quadratic because a quadratic is something that's generally in the format of y equals x squared. So you've got an x squared, and quadratics equal 0. So putting this all together, it'll be really easy to take this equation and subtract t from both sides, and getting it looking like this, equal to 0. And that's our classic quadratic, because in addition to looking like y equals x squared, quadratics typically look like ax squared plus bx plus c equals y, but in a lot of situations we set y equal to 0, so it equals 0. So either of these formats are formats of a quadratic. And when you have a question that's talking about the number of solutions of the quadratic, which is what they're doing right here, that is our red flag that we're talking about the discriminant. Now, what is the discriminant? It's the idea that when you're using the quadratic formula, which looks like this, -b plus or minus the square root of b squared minus 4ac all over 2a, and that's an x on the left-hand side. When you have something like that, with fake numbers, it could work out one of three ways. So I'm just going to make up numbers here just to show you what the discriminant is. 2 plus or minus root 4 over 3. 2 plus or minus root 0 over 3. And 2 plus or minus root -4 over 3. So what are we seeing here? We're seeing that based on the value under the radical, whether it's positive, 0, or negative, that's going to influence our number of solutions. because right here, where we have a plus sign under the radical, the answer literally would have been 2 plus 2 over 3 and 2 minus 2 over 3. So 4 over 3 or 0. So there would be 2 answers. But in this situation here, where we have a 0 under the radical, that would be 2 plus 0 or minus 0 over 3. And when you add or take away 0, nothing happens. So the answer would just be 2 over 3, and there would be 1 answer. And here, you have a negative sign under the radical. And a negative under the radical is not allowed in the world of math, so that's 0 answers, or the famous no solution. So the thing under the radical, that's the b squared minus 4ac. So in a level 1 discriminant question, an easier discriminant question, you'd be given a quadratic and asked how many solutions would there be. You would get it in an ax squared plus bx plus c equals 0 format, and then go ahead and find out the a, b, and c, and plug them into that equation, that expression, b squared minus 4ac, and just judge whether the answer to that came out positive, which means that you'd have 2 solutions, 0, which means that you'd have 1 solution, or negative, which means you have no solutions. But in a harder discriminant question, you'll be given an expression kind of like this, and you'll be told the number of solutions. And you're supposed to know that that's a reference to the idea that the discriminant is either positive, negative, or 0. So in this situation, no solutions, which is this situation right here, means that the thing under the radical, the discriminant, is negative. So we're going to set up an inequality that says that b squared minus 4ac is negative. It's less than 0. Now, by the way, when we subtracted t from both sides to get 0 on one side, we saw that the a was 2, the b was the negative 4, and the c, as weird as that is negative t. So let's plug that into b squared minus 4ac is less than 0. That's negative 4 squared minus 4 times a, 2, times c, negative t, is less than 0. Simplifying, negative 4 squared is 16. Negative 4 times 2 times negative t is 8t, and that's less than 0. Taking away 16 from both sides, we'll get 8t is less than negative 16. And dividing both sides by 8, we'd have t is less than negative 2. Now, by the way, when you divide both sides of an inequality by a negative, when you multiply or divide both sides of an inequality by a negative, it would reverse the inequality. But here, we did not do that. We divided by a positive, but we divided a negative number by a positive. That's different than dividing or multiplying by a negative. Confusing wordings here. But just note that in this situation, we did not divide by a negative. So the inequality stayed in the same direction. And t is less than negative 2. So just imagining that on a number line now, I'm going to put the numbers negative 3, negative 2, negative 1, 0, 1, and 2, and also 3. And if t is less than negative 2, that means that we would want an open circle at the negative 2, and we would want to move in the smaller direction from there. Now, which of the answer choices would still be in that solution set? There's only one, negative 3. And the answer for 13 is A. Now, question 14 is a really valuable question for us, and it talks about a concept that we hope to get into in the near future, which is the idea of converting an equation into an inequality as a solving method. And we're going to show you that here. But whenever you have a difficult word problem, what you want to do is describe your variables. When you have something really longly worded like this, describing the variables will help you stay just a little more organized. So doing that here, D is the number of containers of detergent, and S is the number of containers of fabric softener. So doing the easier equation first, we have our price times quantity statement. Now, price times quantity statements are a nice classic thing that we see in a lot of word problems, and the way it looks is like this. If the detergent is 7.35 pounds, then you have 7.35, which I'm calling the price, it's the number that goes along with each of the items, multiplied by D, for the number. So you got the price times the quantity, and that little expression there represents the total number of pounds of detergent. And we have 6.2 for the fabric softener multiplied by the number of containers of fabric softener, so 6.2s, that's the PQ statement for the fabric softener. And the question tells us that the number of pounds is no more than 300. So all of this has to be no more than 300. It could be equal to 300, or it could be less than 300. So already we know the answer has to be A or B. But now getting into the tougher expression, it says, the service wants to buy at least twice as many containers of detergent as containers of fabric softener. So first off, there's the idea that we're going to set up an equality and convert that to an inequality. We'll talk about that in a second. But also, there's a rearranged wording here. Usually you can take an equation the way it's said and make an equation right out of it. But there are a few wordings that are used where it's very difficult to literally write the equation from the verbal expression. So in this situation, I'm going to first take what they told us, which is that we're going to buy at least twice as many detergent as fabric softeners. And I'm going to say we're going to buy something that's equal to twice the amount of detergent as fabric softener. So far I turned the inequality to an equal sign, just for now, just to stay more organized. But if the amount of detergent that we have is equal to twice the fabric softener, the way I just said it a second ago sounds more natural. So I'm going to change that. The detergent is equal to twice the fabric softener. So what we just did there is we kind of rearranged the wording of what they said. It's exactly equivalent, but it's just in the way that you're able to kind of naturally write an equation from that. Because if the detergent is twice the fabric softener, that's, for us, D equals 2S. So we kind of, in a subtle manner, turn this verbal expression into something that, yes, we could write an equation from. But the detergent is not equal to twice the amount of fabric softener. The detergent is at least twice the amount of fabric softener. So it could be equal to twice the fabric softener, or it could be greater than twice the fabric softener. So that is, the detergent is greater than or equal to twice the fabric softener. And that brings us to answer choice A for number 14. So just to reiterate that, first we took the wording they gave us, we kind of turned the words around a little to make it make more sense to us. We wrote it as an equality, and once we had it organized that way, it was easy to turn it back into an inequality. So it's just the idea of taking a lot of the elements of what they're doing and handling them each little by little, one at a time, separate from one another. And the answer for 14 is A. Now for number 15, we have the idea that if I square a binomial, I don't want to walk into the common mistake for beginners that would say that something like x plus y squared would be equal to x squared plus y squared. So just be careful not to rush and ever think anything like that, because x plus y squared is not equal to x squared plus y squared. If I'm squaring something, I'm repeating it. So something like x plus y squared would be x plus y times x plus y. And then from there, we would FOIL it. So I think that's what question 15 is kind of daring us to do. So here, we're just going to go ahead and take the a plus b over 2 squared, and we'll repeat it like we just said a second ago. A plus b over 2 times a plus b over 2. And then we're just going to FOIL it. So let's put out the FOIL of FOIL. First times first is a times a, and that'll be a squared. Outer times outer is a times b over 2, and that'll be ab over 2. Now, by the way, that could have been a little confusing for some people right there, because one number was a fraction and one number wasn't. So if I had a times b over 2, I want to think of that as a over 1 times b over 2, and that's how we get ab over 2. But going back to our FOILing, outer times outer is once again a times b over 2. So we'll also have ab over 2 for that. And last times last is b over 2 times b over 2, and that'll be b squared over 4. And all these things are being added to one another because we didn't have any negative signs in any of this. And the only confusing part here is that the ab over 2 plus ab over 2 would become 2ab over 2. And then that would simplify because the 2's would cancel, and we would just have ab for that middle term. So that'll give us a squared plus ab plus b squared over 4. And that exactly matches answer choice D for number 15. Question 16 is a question where we have to invent numbers to fit this situation. So we have a situation where you have a base to some power, and all that equals 16. So we can kind of imagine what pairs of numbers could do that. I could say 4 to the second power is 16. I could also say 2 to the fourth power is 16. I could also say 16 to the first power is 16. And there are a couple of ways to do this question, but let's stick with the one we have here, 4 to the second power. And so doing this, that would mean that the thing in the A spot is 4. So according to this set of numbers, we have A equals 4, and the thing in the B over 4 spot, well, that's our 2. So we can say B over 4 equals 2. Multiplying both sides of that by 4 to get rid of the denominator, we'll get B equals 8. So what's one possible value of B? 8. And there were a few different numbers that would have worked there. For number 17, we have a nice simple equation to solve, and we said earlier in this video that to solve for something in algebra, you want to find out what's happening to that variable and then do the opposite. So what's the opposite of what's happening to t? Well, t is being multiplied by a fraction, by 2/3. And what's the opposite of multiplying by 2/3? It's not dividing by 2/3. Well, actually, that's not terrible, but I would think it would be better to say that instead of multiplying by a fraction, you want to multiply by the opposite fraction. So if we had 2/3 t equals 5/2, we want to multiply by the opposite fraction of 2/3, the reciprocal, which is 3 over 2. So that'll cancel. The 2 will cancel with the 2, and the 3 will cancel with the 3. When we do that on the right-hand side, we'll get 5 times 3 in the numerator and 2 times 2 in the denominator, and that's 15 over 4, which is equal to t, and that's our nice simple answer for number 17. Number 18 is giving us similar triangles that are overlapping because they have parallel lines. So in this situation, you would always want to draw the triangles separately. So in our diagram, we're just going to go ahead and draw the small triangle and the large outer overlapping triangle. And for the small triangle, it has sides of 6 and 8. And for the large triangle, we have 18, and we'll call the bottom x. But what we're referring to as x is all of this side AC. But having them in that format, we can just go ahead and use a proportion. 6 over 8 equals 18 over x. Now, by the way, why were these two triangles similar? Well, similar triangles can be similar by something called angle-angle similarity. Angle-angle similarity is the idea that they share two angles. So both of these have angle C in them, so they share that theta there. And because the lines are parallel, I know that if one of them has a right angle, the other one does as well. And the idea of angle-angle similarity is the idea that if two pairs of angles correspond, and the triangles, because they're triangles, add up to 180, then the third pair will also correspond. And what does it mean for shapes to be similar? Similar means they have the same shape and different sizes. And because they're similar, their sides will be proportional. And that's the reason why we were able to write that proportion of 6 over 8 equals 18 over x. Now, a nice blanket rule that comes up countless times in SAT or ACT math is that any time you have a proportion, you should cross multiply it. So here, we're going to cross multiply like that. And that'll give us 6 times x equals 8 times 18. 8 times 18 is 144. So we have 6x equals 144. Divide both sides by 6, and you get x equals 24. So the bottom of the triangle is 24. And if this is 24, and we already had 8 accounted for, we can do 24 minus 8 and find out that this right here was 16. Now we didn't really even need to know that, but on a lot of other questions you would. But now that we know the bottom side of the outer triangle, that enables us to use the Pythagorean theorem. So the Pythagorean theorem says that for a right triangle, you can go ahead and set up this equation, a squared plus b squared equals c squared, with a and b being the legs and c being the hypotenuse. So for the two legs of our big outer triangle, we have 18 squared and 24 squared, which is c squared. 18 squared is 324, and 24 squared is 576. So right now we have c squared equals 900. We can take the square root of both of those, and we get c equals 30. And that's the length of the hypotenuse here. That's 30. And that's what they're asking us for, side CE, which is 30 for number 18. Number 19 is something of a higher level concept we refer to as adding to a mixture. When you're adding to a mixture, you're going to get a statement where you have a percent and a total, and a percent and another total, and they're going to add up to give us a final percent and a total. So in this situation, we have 3 liters of a 10% solution first sitting there. And the wording says that something's going to be added to that. So that's a percent and a total. So 10% of the 3. Now, in these adding to a mixture questions, you also always have the total, and you always have the other part that's the percent of that. So this, imagining that whatever is not salt or saline here will be just pure water. Here we'll have a solution that is part pure water and part saline. And if you try to write an equation about the wrong thing, you'll realize you don't have enough information. If I tried to say what was added to the 3 to give me the thing in the end, I wouldn't have enough information. I have to write an equation about the amount of saline. So the starting amount of saline is 10% of 3. And the question says we're adding how many to that, but the percent of what we're adding is 25%. So notice that we have a percent and a total and a percent and a total. And it's sort of like a story within a story, because for the totals, we started with 3 and then we added x to that. And for the percents, we're told that in the end, it's 15% saline. So at its heart, we're just taking each piece of information and just entering it into an equation, almost unaware that this is going to end up in an answer. But if you can write an equation with what you're given, then it's algebra, so you can solve that equation. So 0.10 times 3 is 0.3 plus 0.25x equals, and then now we can distribute 0.15 times 3 is 0.45 plus 0.15 times x, which is 0.15x. We can take away 0.15x from both sides, and that would give us 0.10x right here. So we have 0.3 plus 0.10x equals 0.45. We can take away 0.3 from both sides, and that'll give us the 0.10x on the left, and 0.45 minus 0.30 is 0.15. Divide both sides by 0.10, and 0.15 divided by 0.10, let's just write it like this because it's the non-calculator section, so we have to be careful not to assume that it would be easy to get the answer here. But for me, I would multiply both of these sides by 100 on the top and 100 on the bottom. That would give me 15 over 10. And by the way, the SAT doesn't require simplified fractions on their free response. But 15 over 10, they can be both divided by 5, and that would give me 3 over 2. And that's the answer for number 19. Now question 20 is asking us about fractions of circles. And the idea about fractions of circles is that if I know the fraction, let's just say that my fraction is 1/4, then I now know that the area of a pizza slice, a fraction of a circle, would be 1/4 of the area of the whole circle, pi r squared. I also know that the arc, the pizza crust, would be 1/4 of the whole arc or circumference of a circle, which is 2 pi r. And we also know that the angle that we're talking about, the angle that pertains to the pizza slice, would be 1/4 of the entire angle of a circle, and a whole circle has 360 degrees. So the moral of the story is that if I know what fraction of a circle I'm dealing with, I can apply that fraction to the area, the circumference, or the angle. Now in this situation, we're being given a circle, and we have an arc, which implies that there's a pizza slice there, and the length of that arc is pi over 3. Now the radius of the circle is 1. Now since we're dealing with arcs, we're going to want to know the entire arc of the circle, which is the circumference. And the circumference of a circle is 2 pi r. If the radius is 1, that means that it's 2 times pi times 1, or just 2 pi. Now if we're trying to figure out what fraction of a circle we're dealing with here, a fraction in general of anything is just the part over the whole. And the part that they gave us, the pizza crust, is the pi over 3, and the whole circumference is 2 pi. So now to figure out the fraction of the circle, we're just talking about dividing fractions. And to divide one fraction by another, we're using keep, change, flip, which means we keep the first number, we change it from division to multiplication, and then we flip the bottom number. We get the reciprocal of the bottom number. So we're going to keep the pi over 3, we're going to change it to multiplication, and we're going to flip the 2 pi and make it 1 over 2 pi. So that'll give us a pi on the top and like a 6 pi on the bottom, but let's just cancel the pi's, and that'll give us 1 on the top and 6 on the bottom. So we now know that we're dealing with 1/6 of the circle, and therefore this pi over 3 piece that we're talking about right here is 1/6 of the whole circumference of the circle. And like we said before, if we needed the area, we now could get 1/6 of the area of the whole circle. Or if we needed the central angle, the theta right here, we could get 1/6 of 360, which would be 60 degrees. But here we're just being asked for the fraction of the circumference of the circle, which would also be equal to the fraction of the area or the central angle. But the fraction is 1/6, and we're done with number 20. Thanks for listening to our answer explanations for College Board's Test 6, Section 3. Grateful provides one-on-one and group online SAT and ACT instruction to students all around the world. Our students have increased by staggering numbers, shown amazing score improvements, and gotten into all of the world's top colleges. And we'd love to help you out, so reach out to us if you're interested, and have a great day.